Hello and welcome! In today's video, I really just wanted to do another application of calculus. I think calculus is a very interesting subject because it has applications to a ton of different fields of math, and one of which was geometry. And in today's video, we're going to be going over one of those applications to geometry, how to derive the formula for a cone. So, how are we going to get started here? Well, I kind of gave us a small little hint here, but cones have this nice little shape. They kind of resemble something on the lines of this. They have a straight axis here. So we're going to use this fact that it has this straight line, and then I'm going to use this fact of having a straight line to rotate it about an axis to find the area of the cone. So, in order to get started here, we have to be a bit more abstract. We can't use numbers, so we're going to use letters. We're going to call this x value, where this line intersects the x-axis, R. We're going to call the y value, where this line intersects the y-axis, H. Okay, so if we want the volume of a cone here, we need to rotate this curve about the x-axis, or the y-axis. But we need to find the equation for this line first. So we know an equation for a line that will have a slope. Well, we know that this line is going to have a slope of negative h divided by r times by x, and then it intersects the x-axis at h. Okay, no problem there. So now what we have to do is, because we're planning on rotating this about the y-axis, is we need to get this function into terms of y. Or terms of like x is equal to y something. So we're really making x the dependent variable here. So we are going to, and the reason for that is we're going to be multiplying. This is the radius x, so we have to solve for this radius x. We're also going to be multiplying it by a very change dy, a very small increase in y for a change in x. Okay, so we're now going to solve for x in this equation. So we have to say y minus h is equal to negative h divided by r times by x. Then we just have to multiply both sides by the reciprocal, so we get y minus h times by negative r divided by h. Okay, well, now we have to set this up. And what is the way that we can add up a large amount of small, very thin, let's say, circles? And the way that we're going to do that is using the integral. The integral actually does stand for sum in many ways. And we are going to be doing this integral from 0 to h. You might be asking, why not r? But this is because we're going to be taking this integral with respect to y. That's why we have this small little change, dy. Alright. Well, what is going to be our radius for the circles? After all, we're adding up a lot of circles here to find the volume of the cube. And the answer to that question is x is going to be our radius. Squaring that. Well, we also have to have a pi, because this is going to be pi times by x squared. Okay, evaluation now. We have pi times by the integral from 0 to h. X squared is actually going to be this function squared. So we get negative r divided by h times by y minus h squared, and taking the integral with respect to y. So we now get pi times by the integral from 0 to h of r squared times by h. And then in parentheses, I have to also apply the exponent here. So we get y squared minus yh, or 2yh, sorry, plus h squared. And we're taking the integral of that with respect to y. We're going to pull out this r squared h, so we get pi r squared divided by h squared, and we're just going to evaluate this integral. So the integral of y squared with respect to y, that's going to be y cubed divided by 3. The integral of negative 2y times by a constant, that's just going to be y squared times by that constant. So that's going to be minus y squared times by h. Alright, the integral of h squared, that's a constant, so that's going to be h squared y. And we're now going to evaluate this from 0 to h. Because all of these terms have a y in them whenever we sub in 0 for y, we're going to find out that's just 0. So we're just going to evaluate this at the upper bound. So we get pi r squared times by h squared. We're evaluating this at h, so we get h cubed divided by 3 minus h cubed, because we plug in the h squared times by h is h cubed, plus h cubed, and then minus 0 for whenever we plug in 0. This h cubed and this h cubed will cancel each other, so we are really left with pi r squared divided by h squared times by h cubed divided by 3. Well, we can cancel the h squared and the cube, leaving just an h, so what we're left with is 1/3 pi r squared times by h, and that is how you derive the formula for a cone. I hope this video has helped broaden your understanding of calculus, and I hope this has also helped you understand where the formula for a cone comes from.